So this is the HDR session, and I want to introduce another HDR expert here. Again, many of you know him. He's Walt Husak, the Director of Imaging Technologies at Dolby. And I will talk this really slow. And it will be, his title of his talk is called Dolby Vision, Production, Distribution, and Display.
All right, first of all, I'd like to thank Yasser, Ali, and Alex for this opportunity to present. I think this is kind of an exciting conference and a really cool place. And so I'm going to talk about Dolby Vision, the production, delivery, and display, where we are, where we're going with this. So Dolby Vision, it was an ecosystem. It was launched quite a long time ago. We started working on HDR about 15 years ago. And over a long period of time, we've discovered quite a lot on it, introduced quite a lot to the industry on this. Dolby Vision itself, was rolled out, as many of our technologies has, as a small sort of soft rollout. And in the modern day, OTT services are kind of vertical and kind of allows us to be able to do that. And in our OTT services, we had all the major studios plus quite a lot of the OTT distributors as part of it. At the same time, we've launched some Dolby Cinema out there. We've got over 100 now. I think we hit 100 a couple months ago. So we're moving along actually rather well. Now, that's all fine and dandy for small closed ecosystems, but over time, some of those ecosystems plus the broadcast ecosystems require standards. And so we've done quite a lot of work on the standards aspect to move vision into standards. We started off with JPEG HDR, still photos, things like that. And then we went to some of the basics, SMPTE, ITUR, talking about baseband, delivery, and interchange, and then moved into some of the MPEG, HEVC work, and then finalizing on some of the distribution work, and then continuing that further on in the cable industry. So some of the big contributions that we had is, we developed PQ and socialized with the studios and took it to SMPTE, explained it to the broad community. It's an excellent transfer function that has no compromises and can represent the deepest blacks to the brightest brights up to 10,000 nits at least as it's been defined with no contouring. We also introduced ICTCP, which was an old print format for producing colors with much wider color gamut than the traditional YCBCR. One of the key things we discovered is as we moved from 100 nit displays to 1,000 nit displays or many more, there were issues that came up with YCBCR. So we introduced ICTCP. And then finally, we sort of introduced the concept of dynamic metadata for display adaptation. And the previous presentation was another version of that same concept. And this allowed the receivers to optimize the content coming into the display's specific capabilities. So currently, we have a number of portals that's transmitting and delivering Dolby Vision. We have a number of studios, Deluxe being the largest, or not studios, but the post and distribution houses, Deluxe being one of the largest ones, but some of the other studios have their own production houses now. We have quite a number of Ultra HD Blu-rays already out there and available. We've got Dolby Cinemas out there with laser projectors. Some of the 4 largest OTT providers, Vudu, Netflix, Amazon, iTunes, and then some of the largest television producers, LG, Vizio, Sony, and TCL, plus a number of Chinese native brands that support vision. So we're actually pretty far along. We've got over 200 movies completed, approved, distributed, hundreds of hours of episodic television that's out there, and we have multiple production facilities in play. So we actually have some bona fides behind us. Now, we're also, been a leader in standards development. We don't do this just for ourselves. We actually do this for the industry, and the industry demands standards. So we're active in the standards. We chair or lead standards efforts in the ITUR, SMPTE, MPEG, ETSC, and DVB. So we're rather active in it. So now let's kind of talk about where we're actually going with it. So, Bill talked a little bit about this. I'll give you a slightly, different viewpoint on it, and hopefully between our two viewpoints, you'll have a good understanding. So display adaptation is kind of key with the advent of different types of technologies that you're buying in your house. No longer do you have just a CRT in your house. You can have dual modulated LCDs, single modulated, OLEDs, QLEDs, all sorts of different types of displays, laser displays. So display adaptation, it's also known as dynamic metadata, adjusts the content in the display based on the target display, what its capabilities are, what the viewing environment is. Not all people's viewing environments are identical to the mastering suite. And then, in many cases, tries to keep the creative intent all the way to the target display. So there's really two types of metadata. The first type is descriptive metadata. In descriptive metadata, the content generally is parameterized, and you send those parameters, and then a unique solution is created at each display at the point of display, and that's based on the content, based on the display capabilities, display on the environment, could be indoors, could be outdoors, and also trims that may be sent from the creatives. Then there's prescriptive metadata, and there's a number of other scenarios that work like this, and particularly Samsung's one of them, one of many of them. And that's the curves are generated upstream. And either those curves, either a large number of curves need to be sent for the type of display and the capabilities of display, or as in Samsung's case, a single curve is sent and then it's either interpolated or extrapolated from that single curve. So if you take a look at what Dolby Vision sends, this is the most basic elements of Dolby Vision. So we have 2094-10, which is sort of the governing document from SMPTE. And then one example is A341 Annex C, that's the ATSC standard, or the equivalent DVB standard. So we break it down into what we call levels, or Ls. So we send the mastering display color volume SCI. That describes what the display was that the content was mastered on. We send the mid-max of the scene. Then we send some specific trims, and this is where the creatives will set the trims. And those trims may be for specific target displays. Most often they send one for SDR, and that way their SDR will be approved no matter what display it gets shined on. And then we have L3, which are offsets. L4 is not defined in 2094-10, and then L5 is the processing window, which we use as a letterbox. And of course, we developed our standard to be extensible, so in the future there may be other elements that's added, and that's kind of the L 6 through 255. So, and that kind of describes at a high level what types of metadata we send. So if we take a look at the high-level functional diagram and the workflow that goes on, we kind of start with content that's always graded. So we'll start with some studio content, and a cinema trim will be developed because that's the first window of release. And then from there, the content can be graded for a Blu-ray release or some sort of physical media release. And in all those cases, the grade is actually held inside of the metadata. So it'll be a 4,000 nit Uber grade with metadata, in this case for roughly 110 nits, and for this case it would be sent parameterized so the television or the display itself could identify the appropriate curve for it. Now from there you would deliver it to a broadcast network where you would have the metadata already embedded. But at the same time, not everything from the broadcast network comes from pre-graded content. So you may have live content coming in. That live content could be graded at the truck or at the site, or could be left ungraded and sent through. That would end up going to a local station where, of course, you might have local content coming in, and then delivered out over the air to an MVPD, or maybe even straight out to internet delivery. Now this signaling here would be a mix of a variety of different sources. So let me dig a little bit deeper into this. So in offline production, we would do a grade, and that grade would be specific to a cinema trim. So you would have cinema trims in there, and then the laser projector inside, or if it was in the case of a regular projector, would create its own curves for it. And at the same time, the video grade would be created for potentially a number of different targets. A 4,000 nit target, a 1,000 nit target, and perhaps a 100 nit target. Could be whatever the colorist decides is appropriate. Now in live production, you may have a variety of different sources ranging from PQ, S-Log3, HLG. In all cases, there are means to convert that to PQ. And then once you get to PQ, basically at the master control, you could either create trims at that point or just pass the metadata or the metadata and trims along. Now, when you get to the affiliate or the O&O, you might get a variety of different sources. You'll have things coming in from the network, might be a ball game, might be episodics, might be whatever. You might have some local advertisements coming in, local news feeds, and perhaps some legacy SDR data. And again, once you hit master control, you'd split out to an ATSC 1.0 feed. That's going to be at least for 5 years, if not some more. And now some of this metadata can be coming from the trims that we had created earlier. Some can be developed on the fly. And then likewise, as you go to distribute out ATSC 3 or send it on to the MVPD or send it out direct internet delivery, you can either pass along the metadata that was in there or add new metadata to where it's missing. And then once you get to the MVPD, again, you're going to have multiple sources coming in. You might have local advertisements. You have the network feed coming in, HBO feeds, things like that, Showtime. A 3.0 feed may come in, or it could be streamed content coming in. In all cases, the HP or the device that creates the metadata would check to see if the metadata already exists, and if it exists, can pass it through, and if it doesn't exist, can add it into the sequence. So in all cases, metadata can be added through the entire production chain. And then once you get to the home, the data can come in either over the air or through some set-top box and delivered to a plethora of devices here, each one with a variety of different capabilities. And those different capabilities, the curves would be generated specifically for those capabilities. So that's the power of a parameterized system. And then finally, once we get into the set-top box to deliver it, you can deliver it via HDMI. Now, in our case, we began before HDMI had created a system for generic carriage of metadata. So we had our own system for the legacy devices. However, the metadata is the same, whether it's being carried through vendor-specific blocks or through the standard HDMI blocks coming out. So we actually demonstrated this in order to get standardized in ATSC. We demonstrated this last year at the model station, WJW. And it was quite an interesting event to do. This is located outside of Cleveland. It's a 600 kilowatt station on a 2,000 foot tower. It's quite interesting because I've been to broadcast stations. Of course, nowadays, if you notice, everything here is all computer. So the guy coming to help me was a computer technician. He, of course, was rather impressed that coax could be measured in inches. He always imagined coax being a tiny little black cable. Didn't realize they had 12-inch coax at broadcast stations. So it's pretty fun. At any rate, we started off with some content. If any of you guys know some of our content, it's lowriders. It's 4,000 nit. It was graded with metadata and everything. Sent to a stream builder onto a Gates Air, an NSYS scheduler and modulator, and then transmitted over there. Once it got transmitted, we had two different systems we were receiving on. The first one was a prototype LG ATSC 3.0 receiver that actually had Dolby Vision in it, but only in the OTT stack. It did not have it in the RF stack. And so we received the signal and played it, and it played an HDR10 signal. So it kind of proved that there's a do no harm, that the signal was HDR10 backwards compatible. And in the lowrider scene, if any of you guys kind of remember it, there's some sequences in there that are kind of bright or have some highlights to them. And those highlights were crushed on that prototype LG. Then at the same time, we received the signal, ran it through a demodulator, and then through a PC that had software in it that was kind of emulating a set-top box because, again, there were no RF stacks last year. And then I literally went out and bought a current model LG HDR TV, plugged the computer into it, and compared it against the two television sets. And you could actually see the difference between where the highlights were blown out and where the highlights were toned down. If any of you guys were at NAB, and actually almost, virtually any time you look at WJW's demos that they have, it shows this content still playing there. So it's kind of, nice that they're still playing our content. So, and then for some of the other demos, particularly at ATSC and at last year's SMPTE conference, we took that same PC, sort of modeling a DVR in that case, because we recorded the signal and kept playing the signal out, and of course playing it to the two different televisions. You could see it with and without the metadata. So one of the other things that we were tasked with demonstrating was the use of captions and overlays and graphics, because there was some question that the dynamic metadata would cause issues, pumping of the imagery or pumping of the graphics or overlays. And so we showed a variety of different sources coming in. We showed a HiSilicon set-top box that was sort of demonstrating a cable system, an Apple TV demonstrating an OTT system, and then an LG Blu-ray player playing a Blu-ray. And in all cases, we allowed the users to turn graphics on and off and demonstrate that no harm was being done. And it was a mix of a variety of different HDMI sources, because it was a variety of different categories of playout devices. So one of the key things that I wanted to really point out here is how embedded we are in the standards system. A lot of people think, Dolby proprietary, all that kind of business. Wait till you check out this graphic. So we started off with Dolby Vision, right? And it was a concept. Then we first kind of took it to Blu-ray. We showed it to some of the studios. The studio said, you got to put this in Blu-ray. So we started launching Blu-ray. But in order to launch it in Blu-ray, we needed to have some fundamental standards from SMPTE and from ITU. So we participated to develop that. And then from there, we, of course, had to go to MPEG to get some SCI messages, some VUI signaling, and then to ETSC to come up with a means to be able to construct the signal in the Blu-ray. And then from there, of course, we need HDMI, because we need to connect the Blu-ray to the television. And of course, that's both HDMI and CTA. It's not one or the other. So, and then we kind of moved into the OTT world, and we needed to do some work in Dash and some work in CMAF. And then, of course, iTunes has their own, so we had to work with them for HLS. And then we went to ATSC to launch off the effort for over-the-air. And we're continuing to work with the Wave folk to get standardized there. And then, of course, now we're working at DVB, and hopefully in the future with SCTE. So you can see we've been rather busy over the last year or so. So some of the key points here is that we're a pioneer and a leader in HDR development. I think we kind of have the bona fides to back that up. Descriptive metadata really provides the optimal display adaptation system. It allows any kind of display, any kind of content. Dolby Vision ecosystem exists and has existed, and it's being standardized. And Dolby Vision's been publicly tested and demonstrated, both commercially and through the standards organizations. So I thank you and open the floor to some questions.
So any questions out there? Okay.
Hi, my question was, I noticed on your display, on one of the charts you had there, that Rec 2020 was correlated with 4,000 nits.
Yes.
Can you do Rec 2020 at 2,000 nits, or does the nits correlate to the color space?
I know what you're talking about. Right there, right? Yeah, that was a mistake. It should be 2100. Although technically, 2020 is not really defined for a brightness level. 2100 is the first one where a brightness level was introduced. So in some ways you're right, but I can beg off and say, ah.
Okay, one more, and then I got to get the next speakers.
There's an interesting situation today where a couple billion devices can introduce this capability in software. Game consoles, Apple devices, and so on have already done that. But then you get into an issue of whether the device is doing the intelligence of HDR tone mapping or whether the display is. And you know, today there aren't a lot of displays that can do this, but there are a lot of sort of HDR10 capable or high brightness displays that can show the picture if the device has the smarts to do this. So how do we get coexistence between smart set-top boxes and mobile devices versus the displays that they plug into?
So inside of our ecosystem, we do an interrogation back and forth, particularly if the devices are separated via HDMI, for instance. We do an interrogation back and forth, and the two devices will decide which is the better location. Almost always it's the display, because the display has already been parameterized and knows what it can do. But there are times when it's better to actually do it in the source device, be it a set-top box or a Blu-ray or whatever. So we interrogate back and forth. Obviously, a single unit like an iPad or something like that, it's all in the unit itself. Any other questions or comments? I got 30 more minutes.
Yeah, we reset the timer. Please give a round of applause to Walt. And